Hello everyone, you are welcome to today's class. So in this class, we want to look at questions on the joint and partial variations. So we have about 10 questions here as well. So the first question is asking us, so we have m varies jointly as r squared and as l. So we have three variables there. So we start with the first one, m varies jointly as what r squared and as what l. So that is the simple interpretation of it. So we have combined two direct variations together. So this is direct variation. As I've told you earlier on, that joint variation could be the combination of what direct variation and joint variation, or direct variation and direct variation, or joint variation and joint variation. So depending. So this one is under direct. So then we change this symbol to what equals to what. Then we introduce our constant k r square what l. So we are given that m equals to 20, l equals to 8, while r is equals to what 2. Find a constant. So we want to get the value of the constant here. That's the first question we asked to find. So how do we do that? It's straightforward. We put the value of these variables into this equation. So that means we're going to have 20. So we replace m by 20. K, we don't know the value of k, times r squared, that is 2 squared, times l, that is what 8. So that means we have 20 equals to 4. This is 2 times, so that is 4. 4 times 8, that is 32k. So the next thing is to divide both sides of the equation by 32. So in that case, we're going to have this divided by 32, this divided by what 32. So 32 cancel 32. So k will then be equals to 20 over what 32. So 4 can go here 5, and 4 can go here what 8. So we have 5 divided by 8. So we can leave it this way, and we can change it to decimal, but the option given here is all of them are in what decimal. So we check that out. So 8 in 5, that is 0, right? So we add 0 to 5. So 8 in 50, that is 6, which is 48, remainder 2. 8 in 20, that gives us 2, which is 16, remainder what 4, add 0. 8 in 45, so that means it is 0.625. That is option D. Then we go to the next question, number 2. Question number 2 asks us to find m varies. It's the same question. So the question is, find the log connecting these variables. So since we have known the value of the constant, we just put the value of the constant into the equation. What is the equation? The equation is m equals to k r squared l. So put the value of the constant there. That will be m equals to 0.625 r square l. So 0.625 r, that's option C, as we have it there. I hope I'm making some sense. All right, for number 3, for question number 3, we have so it's the same question. Find r when m is equal to 400 and the l is equal to 10. So we are looking for r. R is what we are looking for. So m is given to be 400 and l is given to be what 10. So that means we put the value of everything. That will be going to be 400 equals to 0.625 times r squared, that's what we're looking for, times l, which is 10. So from here we have 400 equals to 625 times 10, and that's going to be 6.25 r squared. So divide both sides by 6.25. 6.25, right? So that means we're going to have, so that means that, so we divide this, cancel this, so r will then be, when you divide 400 by 6.25, we're going to have 64. So the next stage, r squared, rather, this r squared, so it is r we're looking for, not r squared. So then we're going to square root both sides, therefore r will then be equal to square root of what, 64, then r is equal to what, 8. So that is option A. How this is very clear. So let's go to question number 4. So question number 4 is another set of questions. So let's read that. Question 4. If D is directly proportional to the cube of R and inversely proportional to the square root of H. So let's interpret that. D is directly proportional to cube root of R, that is R cube, and inversely, that is 1 over the square root of H, square root of what, H. Right, so we have interpreted this. So that is going to have D equals to K R cube all over what, square root of what, H. So find D in terms of R and H, given that D is equal to 25 when R is equal to 3 and H is equal to what, 16. So that means, what this means, the question means, is that you find the relationship between the variables. So you can see D in terms of R, which is this, and what, H. So the constant is what you're going just to put there. So let's see how to go about this now. So we have this. So we have been given that D, so given that D is equal to 25, R is equal to 3, and the H is equal to what, 16. Let's now put this in this equation. So that's going to be 25 equals to K, which we don't know, multiplied by R, that is 3 cube, divided by square root of what, 16. So from here we find the value of R constant. So this is going to give us 25 equals to 3 cube is 27K, square root of 16 is 4. So you can then cross multiply here. So you can cross multiply, that's going to be 27K. Let me divide this. 27K equals to what? 100. So 25 times 4 is 100. So we divide both sides by 27. So this cancels this. So we can therefore say that K equals to what? 100. That is K equals to 100 over 27. So the question asks us to put, because we want to get the relationship between the variables. So we then put, so that will be D equals to 100 over 27, and then R cube, excuse me, alhamdulillah, over square root of what, H. So that means 100 R cube divided by 27 square root of what, H. That is option A there, as you have it there. Then move to question number 5. For question number 5, so we have the same question. Find the value of H. Find the value of H when R is 3 and H is 16. find the value of h when this is 50 and r is 4. So the first thing we bring out the formula we have there, d equals to 100 r cube all over 27 square root of what? H. So we have the value of d to be 50, then the value of r is equal to 3. That is going to be times 3 cube. Everything divided by 27 square root of what? H. It is h we are looking for here. So that means we have 50 equals to 100 times 3 cube is what? 27 all over 27 square root of what? H. This cancels this. So that means we have 50. So we cross multiply 50h equals to what? 100. So we can divide both sides by 50, right? So that means h square root of h equals to what? 2. It is h you are looking for. We square both sides. So this cancels this. So h equals to what? Equals to 4. That is option what? Option A. Now the next one is another question, and this one is under partial variation. So that's another subtopic. Hello, all right. So we continue question 6 now. On question 6, we have m. We're going to solve it here. So I don't want to separate the pages again. So m is partly constant. So there are two, under partial variation, we have two constants. We're going to have two parts. The first one here is partly constant. That means we're going to have m. Let me put it here. All right, m equals to partly constant, that's equal to plus a, then plus partly varies as n squared. The second constant is b, then n squared. So that is the equation. Then we're going to have two whens. That is, when this is that. So now let's look at the first one. So this will now make us to form two equations. When n is equal to 2, m is equal to 17. That is, m is equal to 17 and n is equal to 2. That is b times 2 squared. So which is going to give us a plus 4b, that is 2 squared is equal to 4, equal to 17. So this gives equation what? 1. And the second one is when n is 4, m is 53. So that is 53 equals to a plus b times 4 squared. So this is going to be a plus 16b equals to 53. All right, so this gives equation 2. So we can bring the two equations together. Let's close this. So that's means we're going to have a plus 4b. Let me check if it's there. Okay. A plus 4b equals to 17. And then a plus 16b equals to 53. So this is another opportunity for you to solidify your understanding of simultaneous equation. So here we have two equations. We're going to solve it simultaneously. Now if you look at the variables, so variable a has the same coefficients in both equations, while b have different coefficients in both equations. So in that case, we can use the elimination method by subtracting a minus a gives us 0. So in that case, we can subtract, sorry for the writing, I'm trying to manage the space, subtract 1 from 2. So that's going to be a minus a 0. Then 16b minus 4b will give us 12b equals to 53 minus 17. That gives 36. So divide both sides by 12. So 12 cancel 12. Then b is equal to what? 3. All right. So we can then substitute b equals to 3 in any of the equation in 1. So, and the 1 is a plus 4b equals to 17. So that is a plus 4b, that is 4 times b, that is 3, equals to 17. So therefore, a plus 12 equals to 17. So we can then, that will be a equals to 17 minus 12, that's equal to 5. But the question asks us to find the equation connecting m and n. So we are now going to replace a and b in this equation here. All right, we replace a, and that will be m equals to a, which is 5, plus b, which is 3, that is 3n squared, and the option is this here. I hope this is very clear. Okay, move to question 7 now. Question 7 is a continuation of question 6. M is partly constant and partly varies as n squared. So find n when m is equal to 32. So we are given the value of m equals to 32, and we're looking for n. So we're making use of this as well. We're making use of the equation we just formed now. So this relationship, we're making use of this. All right. So what we're going to do now, coming, let me check if this is showing. Okay, everything is showing. Okay. All right. So what we're going to do now is we're going to say m, which is 32, equals to 5 plus 3n squared. So we then have collect like term, that will be 32 minus 5 equals to 3n squared. So this will give us 32 minus 5 will give us 27. All right, 27, and that's going to give us 3n squared. So divide both sides by 3. So therefore, n squared equals to 9. Therefore, n is equal to square root of 9. N is equal to 3. And that is the option we have here. I hope this is very clear, right? So that is that. I'll move to question 8 now. All right. So we have P varies partly as Q. So this is quite different from the first one, question number 7 here, which is M is partly constant. So there's no variable there, it's partly constant. But here then we have a variable with the first constant. So that's going to be P varies partly equals to partly as Q, that is AQ. So this A here is the first constant, Q is the first variable, plus partly as the square of R, that is second constant, square of R, that is R raised by 2. So we can then have the simultaneous equation from here. So when P is equal to 6, right, Q is equal to 8, and then R is equal to 4. So the next thing is now to put the value of P. So we put the value of P, value of all these variables in this equation. So that's going to be 6 equals to Q, which is 8, that will be 8A, plus B, R squared, that is 4 square B. So which we can have it to be 8A plus 16B equals to what? Equals to 6. So this will be our first equation here. So move to the second one. So when P equals 10, Q equals 12, and then R equals what? 5. So here too we do the same thing. So that's going to be 10 equals to Q is 12, that is 12A, plus R is 5, that is 5 squared B. So which we can rewrite as 12A plus 25B equals to what? 10. This will form our equation 2. 5 squared gives us 25. That's how we got 25 here. 4 squared gives us 16. That's how we got 16 here. So the next thing is now to combine the two equations together and solve them simultaneously. So in that case, let me rule this one out. So that's going to have A plus 16b equals to 6, equation 1. And then this other one, 12a plus 25b equals to what? Equals to 10. This is equation what? Equation 2. So from here now, so you notice that none of the constants a and b has the same coefficient in both equations. So in that case, what are we going to do? So if you don't want to use another method except elimination, you can use another method here. But if you want to use another method here, you are going to get you're going to have fractions that you'll be substituting, and we don't want to avoid some kind of stress. So what you're expected to do here is we can still make one of the variable, the constant a and b, to have the same coefficient in both equations. How? So the first a, in equation 1 we have the coefficient of 8, while in equation 2 we have coefficient of what? 12. So we can make both of them to be equal. So if I should multiply 12 by 2, I'll get 24. And if I multiply 8 by 3, I'll get what? 24. So which means I will find the LCM of 8 and 12, which will give me what? 12. So that's how to get the least number that you can convert both of them to. Because some students will multiply this by 12, and some will multiply this by 8. They are very 100% correct. But this will give you a very big value that will stress you, and we are trying to be out of stress, right? So what we're going to do, we find the LCM of the two numbers, and then multiply by. So when you get the SM of two numbers, then you divide them. So the SM of 8 and 12 is 24. So 24 divided by 8, that gives this. So which means I'm going to multiply this by 3. And when you divide 24 by 12, it give you 2. So multiply this number by 2. So when we multiply this together, so 3 times 8 will give us 24. That gives us 24a. Sorry, and push this one back. 24a plus 3 times, that's 48b, equals to 18. So this will give us equation 3, right? So the same thing, 2 multiplied by 12, that's 24a plus 50b equals to 20. So we're then going to solve these two simultaneously. So it's going to be easier for us to solve now. So what we're going to have, so we subtract. So 24, we can say subtract 2, subtract equation 3, equation 3 from equation 4. So this will give us 2b, while this will give us what's 2. So divide both sides by 2. So this cancels this. So then b equals what? 1. So we can then substitute the b equals to 1 in any of the equations. So that means we can, let's make equation, substitute equation b equals to 1 in 2. So and 2 we have 12a. So we have 12a plus what's there? 12a plus 25b equals to 10, plus 25b equals to what? Equals to 10. So wherever we see b, we put 1. That's going to be 12a plus 25 times 1 equals to 10, and that is 12a equals to 10 minus 25, and that means 12a equals to minus what? 15. And then so we divide both sides by 12. By what? By 12. So we then get a equals to minus 1 point. So let's check if that's going to be 1 point. So 15 divided by 12, that gives us 1.25. 1.25. Don't forget, what we are asked to find here is the relationship. So we'll now go to the question again. P equals to A, which is this. So we have AQ, that is minus 1.25Q plus B, which is 1, R squared. So this is going to be our answer, and that is option B. Option B. So this will then be used to solve question 9 and question 10. For question 9 now. For question 9, so question 9 asks us to find. So question 9, find the value of P when Q is 15. So we are looking for P when Q is 15 and R is what? 12. So that means P equals to minus 1.25 times Q, which is 15, plus R squared, which is 12 squared. So this will give us minus 1.25 times 15 now. 1.25 times 15 gives us minus 18.75 plus 144. 12 squared is 144. That means 4 minus 18.75. That gives us 125.25. And that is option B. Why the last question? So last question, number 10. Number 10. So find the value of R when Q. So we are looking for R. So Q equals to 4 and P equals to 20. Let's bring the equation as P equals to minus 1.25Q plus R squared. So it is R we are looking for in this case, and that means P is 20 equals to minus 1.25 times 4, then R squared. So that is 20 equals to, so 1.25 times 5, that's going to be times 4, that's going to be minus 5 plus R squared. So that will give us, so that is 20 plus 5 equals to R squared. That means R squared equals to 25. So R equals to square root of what? 25, which is equal to what? 5. So the answer is 5. That is option D. So that is that on this question. As you just need to take your time to watch it. You can try to watch it as many times as possible so that you get the concept clearly. So we meet in our next video. Thanks for watching.